All right, let's do practice problem 5 on page 122 in chapter 6. And here's the problem. It says, in the book, it says, right here, it says, your hand exerts a 6.5 Newton upward force on a pound of sugar. Considering the force of gravity on the sugar, what is the net force on the sugar? Give the magnitude and direction. And so let's do that. Give and find, and so I've already set it up with given. Here's somebody's hand holding up 1 pound of sugar, and we're applying an upward force on the sugar of 6.5 newtons, and wants to know what is the net force acting on that bag of sugar. Well, let's draw a Freebody diagram. So I'm just going to draw the sugar as a rectangle. Bags of sugar are rectangles. And so here's what we've got. We've got gravity. Here's the force of gravity pulling it down, F sub g. Call it the force of gravity. And then we've got this force like this. This is the force of your hand on the sugar. Now this is a force that you are applying to the sugar. So I quite often call it F sub A, and the A here stands for applied force. And we know what this is. This is 6.5 newtons. Now the net force is equal to, is what you get when you sum all the forces acting on the object. Have you seen this symbol before, the summation symbol? You're going to add them together. And but remember that forces are vectors, so I have to add them together as vectors. And if I look at this, if I'm just going to make up positive, well, the force of gravity is therefore a negative force. Or it's pulling down. I'm going to make down negative, which we usually do. So really, when I add these forces, I'm really subtracting them, right? Because they're in opposite directions. Now, the problem here, and then this will be equal to ma, but that's not what they're asking for. We're not asking for the acceleration. They're just asking for the net force. So I'm going to add them up. So I'm going to say, well, when I sum the forces, I'm going to say, well, it's Fa minus Fg. That's going to be equal to the net force. Oh, and one thing, when I make it minus, see how I've made it minus here? That means I don't have to, I've already accounted for the fact that it's in the negative direction. So don't put another negative in there, otherwise you're canceling things out. Now this is 6.5 newtons, but this is 1 pound. Now, I can't add newtons and pounds together. If I do, I will literally crash a spacecraft into Mars. Have you ever heard that story? In 1999, NASA sent a probe to Mars, and it didn't. I think. See, that was the. It was going to be an orbiter. But so it was going to orbit around Mars, but what happened is the trajectory of the spacecraft was wrong, and it went too close to the atmosphere of Mars, and it kind of broke apart and crashed. Why? Because NASA thought that they were getting units for their thrusters in newtons, where the contractor, which was I think Lockheed Martin, was giving them thruster data in pounds. And because of that unit mix-up, the thrusters on the spacecraft were firing for too long. And so it overcorrected its trajectory, and it was just going in the wrong path, and it smashed into Mars instead. So it was unfortunate. It was an unfortunate, very sad situation. So it's very important that we put everything in newtons. Well, if the force of gravity is equal to, that is the pull of gravity is equal to 1 pound, that's the weight of the object. Remember, your weight is a force, and it's the force that Earth pulls down on you with. Okay, so it's 1 pound. Well, I don't know, did you look up the conversion factor between pounds and newtons? Well, so, hey Siri, what's the conversion factor between pounds and newtons?
What would you like me to convert 1 pound to?
Newtons.
Sorry, what would you like me to convert 1 pound to?
Okay, Siri has disappointed me once again. I'm smarter than Siri. 1 pound is equal to 4.45 newtons. So a newton is a smaller unit. I think it's in the book, or I may have mentioned it in the last lecture. I don't remember. But 1 pound equals 4.45 newtons. So, and by the way, if you just Google it, you know, that'll, if you can't remember, you just Google it. If you're taking a test or quiz, I'll tell you, you know, but I don't usually give things in pounds. So, 1 pound is 4.45 newtons. Well, we have 1 pound of sugar. So when I add these together, I'm going to say, well, the applied force is 6.5 newtons. But we're going to subtract 4.45 from that, and so that's going to give me a net force. Well, what is 6.5 minus 4.45? I believe that'll be 2.05 newtons. Is that right? And what direction? Up. Up, because it turned out to be positive. In other words, I'm applying a greater force up than gravity is pulling down. Now, what does that mean is going to happen to the sugar? It's going to accelerate up. It's going to accelerate up. Oh, got to include the direction. And there's my answer. Okay. That was kind of disappointing, very disappointed in Siri right now. But that's the way it goes. Can't depend on technology, you have to think. All right, any questions? Okay, that is all.